Hello everyone. Today's lesson is on domain and range. Okay, we might have thought of the domain and range before as the domain being x values and the range being y values. Okay, so let's go back and in fact just revisit a couple of definitions. Okay, the first one here is a relation. Remember, a relation we've seen as an equation. An equation we can insert some values and create a table of values, and then from that table of values we can get a set of ordered pairs and then we can graph it. So a relation can be any combination of those. Now, some relations are functions. Okay, now remember that the only relation that is a function is this is if the x value has only one distinct y value. So x of a certain value can't go to more than one y value. We used a couple of, like on graphs, we used the vertical line test. I think everyone is kind of got that snapped up. Okay, so let's look at today's stuff. So today we're looking at domain. Domain is x values. X values are inputs or independent values, okay? They go on our x-axis, okay? On the graphing that you did last week, the independent values or the x values went left and right, okay? The range is the y values. They're the output or the dependent values. And remember, they would have on our graphs gone up and down on our vertical axis, which is our y values. Now, whenever we go to list these, right, we always list those values in increasing order. So think about a number line. We want to go from the lowest value to the highest value, okay? So we're going to start with some examples here. So the first thing that we want to do in these examples is we want to state the domain and the range. Remember, those are the x values and the y values. And we want to state whether it is a function or not, okay, which is what we did a few lessons on. Okay, so let's look at this. First example. So our domain here, remember, is the x values. That is the input. So these are going to be our x's or our domain. So our domain values, there's 3 of them here. Remember, we have to go from lowest to highest. So -2 is the lowest. Then we go to 1, and then finally 3 is the highest. Those are our 3 values there of x. Our output or our dependent variables are our y's. So these are the y's, and again, they need to be listed from lowest to highest. So -4 goes first, then 0, then 12. Now, when we have distinct or discrete numbers like this, where it's not a range of points in between, we have to list them in this set of curly brackets here, from lowest to highest. Now, the next thing is to determine whether this is a function or not. So notice we have this single value of x going to 2 values of y. So this is what makes it not a function. So in fact, this one is a no, okay? So that was a mapping diagram. Our second example here is a table of values. And it's obvious to us here, these are listed as the x, which is going to be the domain, and this is the y's, which is the range. Now, I find that students get mixed up on domain and range all the time. So here's a way to remember. There's a tail hanging down on an R, and there's a tail hanging down on a Y. So range and Y go together, okay? So let's list our domain. Starting off here. Remember, these are domain is our x values, and we have to go from lowest to highest. So this has been listed lowest to highest for us, so just simply put in these discrete values. So -3, -2, -1, 3, and 4, lowest to highest in the curly brackets. The range is the y values. Again, tail hanging down, tail hanging down. In the curly brackets, lowest to highest. So 4 is first, 1 is first, then 4, then 9, and then 16. Next is determine if this is a function or not. So we had all single values of x not going to more than one value of y. So this one, yes, is a function. Now moving on to graphs. So remembering that domain is x, so this is our x-axis, and the points are sitting here at -3, -1, 0, 1, 2, and 3. So just listing them from lowest to highest. This is easy on a graph because that's the way they're displayed. In the curly bracket, -3, -1, 0, 1, 2, and 3. Okay, for our range, we're looking at our y values. Remember the tail hanging down, the tail hanging down. Oop. And so our y values going from lowest to highest here is -2, -1, 0, and 1. So listing them, -2, -1, 0, and 1. Now, on a graph, it's easy to determine whether this is a function or not. Remember, we're looking for our vertical line test. So going up and down, do we have more than one point that we cross on the vertical line? No, so this, yes, is a function. Okay, let's go to our second example. Again, domain is our x's, so we start at -2, -1, and then +2. In the curly bracket, lowest to highest, -2, -1, and 2. The range is our y values. Remember, tail and tail for range, and those are going up and down. So start with our lowest. We're at -3, -2, -1, 1, and 2. So -3, -2, -1, 1, and 2. Commas between them in those curly brackets. Now we want to determine if this is a function or not. So use your vertical line test. Bang, we hit 2 points here, and bang, we hit 2 points there. So this is not a function, so there's a no. Okay, so these 4 examples that we've just done are discrete relations. So this is where we're looking at individual points, right? Specific points. Not all domain and range is discrete. We're going to do some examples now where we have some continuous relations. So remember, in a continuous relation, we have a line that is connecting the points. Okay, let's look at this first example. So we have 2 points here and here that are shaded in to show that those points are part of the graph, but so are all of the other points along that line. So when we have a continuous graph, we need to think, what are the highest values and what are the lowest values? So the highest value is here on our x, right? And that would be, in fact, 5 or +5. And our lowest value is over here on the left side, which is, in fact, -3. And the x values, because they're all joined, are, in fact, between those two numbers. Okay, so the domain is between the highest number of 5 and the lowest number of -3. Now let's look at the range. So what is the highest and the lowest of the y values? So looking at y starts here at the lowest value and go up to the highest value here. So our lowest value is, in fact, down here at -3, And our highest value, whoops, with the x, I went the wrong way. I went highest first and then lowest. Let's just change that around. Sorry about that. So our lowest value was -3 and our highest value was 5, +5. Okay, let's go back to the range. So the lowest was -3 and the highest is +2. So again, because there's a line connecting those points together, the range is going to also include all of the points between these two numbers. So we can't just list the individual points. Somehow we have to show that it's every point on that line between those two numbers. So remember, domain is x. So that means x is going to be smaller than the highest value, but bigger than the lowest value. So we use these greater than or less than symbols. So x is in fact smaller than the highest value, which is 5. But it can also equal 5, so we put that half of an equal sign underneath. X is also greater than or equal to the lowest value, which we said was -3. So x is smaller than the 5 or equal to it, but it is greater than the -3 or equal to it. Let's move on to range. Okay, range is y, and again, it is smaller than or equal to the higher value, which is +2, and it is bigger than or equal to the lowest value, which is -3. Okay, always the smaller number on the left side and the larger number on the right side. Okay, now determining if this is a function or not, using that vertical line test, right? You don't cross that line ever more than once. So this, yes, is a function. Okay. So for discrete, remember, discrete points, we're going to list the coordinates individually, and we're doing that in those curly brackets. For continuous, that means a line, we're using this greater than or less than and equal to symbol. It may not be equal to, okay? So you may not have that half of an equal sign underneath. Same thing for the y's, we're using the greater than, less than, or equal to symbols. Now, one more thing I need to point out is if the line doesn't stop like we had in this graph, it stopped at that point there and it stopped at that point there. It doesn't have an arrow on the end. Many of the graphs that we've done in the past have had arrows on the end. That means it goes on forever. And forever means infinity. Now, if it goes on forever as an x value in the left direction, that would mean it's going to be negative infinity. If it's going to go on forever in the y direction, it would be down for negative infinity. For positive infinity, for the x value, it's going to go on with an arrow to the right for x's, and it's going to go up with that arrow forever with the y values. Now, sometimes the arrows go both left and right on infinity or up and down infinity. So if both sides are infinity, we say that it is going to encompass all the real numbers. So that would be if x is going to go infinitely to the left and right, x is going to encompass all the real numbers. For y to encompass all the real numbers, it's going to have to go up and down infinitely. Okay, so it's going to continue on up and down infinitely. Okay, let's go through some examples. And again, we want to be able to use proper notation. So in example 3, we're looking for domain, that's our x values. So our x's are 1, 2, 3, 4 here. These are discrete values, so they go into a bracket, a curly bracket. Remember to list them from lowest to highest. So -1 goes first, then 1, then 2, and lastly 5. Now, this is continuous where it's a between, okay? So remember, we're talking about x here. So x is going to be between two numbers. Our lowest goes on the left and our highest goes on the right. So 5 is higher, -3 is lower. So x is going to be less than or equal to the highest value, or greater than or equal to the lowest value. Let's look at the third example here. It says in negative infinity. Okay, so negative infinity means that it's going to have an arrow going on to the left forever, and its highest value then is going to be the -3. So this is the lowest and this is the highest. So x is going to be between these two values. So x is going to be smaller than or less than or equal to the -3, but greater than or equal to negative infinity. Okay, let's move on to example 4. This is the y values. So we're looking at the range. Okay, so y values for discrete go in a curly bracket. Remember, ordering them from lowest to highest. So -2 goes first, then 0, then 4, then 6. For continuous values, we're looking at y. So y is going to go between the highest value here and the lowest value there. Okay? So the lowest value is -1 and the highest value is 6. And it's going to be less than or equal to the highest value or greater than or equal to the lowest value. Again, the y value, because we're talking about range here, this is the lowest value and this is the highest value. So positive infinity is the highest value and 3 is the lowest value. So x is going to be less than or equal to the highest, greater than or equal to the lowest. Okay, now that we've got this, hopefully, use of symbols done correctly, let's go to some more examples where we have to do a variety of things. So the first thing on the next set of examples is to determine, is the graph discrete? That means it only has points. Is it continuous? Now, continuous means that it connects the points, but it has an end on those graphs. That means that I don't mean that it ends in a point. It could end with an arrow or it could end with a point, okay? Because there is a possibility that it's neither, and that's where the ends loop together. So they could loop together in a circle or in an oval or even in a square or a triangle. Those are where the ends have actually looped together, and that's going to be neither discrete nor continuous. Okay, so you have to determine which of those three it is, and you can just circle. The next is the domain. Remember, that's the x values. The third is the range, which is the y values. And lastly, determining if it's a function or not. Okay, so A, is this discrete, continuous, or neither? So there is, in fact, a line that is joining the points together, but the ends are not connected together. So, in fact, this is continuous. Okay, let's go through. You might as well do the first step with all three of these. Again, there is a line, right, that joins all the points together, but the ends are not joined together. So again, this is continuous. And the same thing with the third one. Now, you can have arrows on the ends as long as the ends are not connected together. And the line connecting all the points together means that it's going to be continuous. The second part is to determine the domain. So remember, the domain is the x values. Now there's something slightly different about these two graphs in that these ends have these open circles, but this one has a closed circle. So the open circle means it's not actually equal to. So the line goes right up to that point as close as it can get, but it never actually reaches that point. Okay, so we can't use the equal sign. So let's look at what this looks like. So we're doing our x first. So remember, x goes left and right. So our lowest value is there and our highest value is here. So the lowest value is going to be at -3. Our highest value is going to be at 4, and x is going to incorporate between those. Now, x is less than 4 but not equal to it because it's not been shaded in, so we don't put that line underneath, right? X is greater than this lowest value, which is -3, but again, it doesn't have that shaded in, so we can't use the equal sign. Let's move on to do the x value on the next one. So it's going to go from here to here. Okay, so x is going to be between those. So the lowest value is at -3 and the highest value is at 4. So the ends are different. One has a shaded circle. So that means that x is going to be less than, but it's also going to be equal to because that end is shaded in. For the lower end, x is going to be greater than -3, but it's not equal to it. So we're not going to put that line there. Okay, let's look at the last example in this row. So the range of numbers, or the domain of numbers, goes from the lowest at -4, but then these arrows continue on. So in fact, it's going to continue on infinitely going to the right in both directions there. So our x is going to be on this end having positive infinity because it's going on forever. Those arrows continue. So x is going to be less than or equal to positive infinity. And on this end, we have -4. Okay, so it's going to be greater than or equal to -4. For part C, this is our range, which is our y values. Okay, so the y's are going to go up and down. Okay, so we go from there to there. So remember, our lowest value is going to be -3, and our highest value is going to be +4. So we're looking at the range, which is y, and y is going to be less than the highest value, which is 4. Remember, not equal to because it's not a shaded circle. And it's going to be greater than, but not equal to, again, the lowest value, which is -3. Okay. Moving back to the second example for our y's, it goes as high as here, and it goes as low as there. So our y's are going to be between that. So the highest value was, in fact, +3, and the lowest value was -3. So the y is going to be greater than or equal to that highest value, right? Which is in fact here, and that point is shaded in. That's why it's equal to the highest point, which is 3. Even though it ends here at 2, the line went up above that 2, okay? So it's not just the ends, but it's the highest point that it would have gone to. And y's lowest point is not equal, so it's just going to be greater than, but not equal to the lowest point, which is -3. Okay, let's look at the y values of the third graph here. So right at this point, we have it here and here. But look, if this line continues on, the y is actually going to go on, continue to rise up. And the same thing here, if that went on, it would in fact continue to go down. So it's all of those points in between, but it's going to continue to go up in the positive infinity and down in negative infinity. So you could have y being greater than or equal to positive infinity and greater than or equal to negative infinity. Or you could use the simpler notation, which says y is going to encompass all of the real numbers. Either of those is correct. Okay. Now, the last thing we need to do here is this a function or not? Remember, just use your vertical line test. Boom, 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 boom. When you think about that, this is going to be a function, yes, because the line doesn't cross the vertical pencil or vertical line test more than once. Go to this one. It doesn't matter where we put our vertical line. Again, it's not going to cross the line more than once. So yes, this is a function. The last one, bang, it's going to cross in 2 points. So this one is no, not a function. Okay, just a couple more to do here. A few more. Let's go through this quickly. Now that we got this down pat. Okay. The first is to tell whether it's discrete, continuous, or neither. Because this is a circular loop where it joins back together, we are talking about neither here. Okay? This has discrete points, no line. This again has also discrete points, so no line. So it's discrete. Here, the second part B is for the domain, and then the range. Remember, domain is x and range is y. So the highest and the lowest values of x. So we're going between here and here. So x's highest value is going to be 2. It can equal 2, so it's going to be less than or equal to. Our lowest value is -4, so it's going to be greater than or equal to -4. For discrete, remember we're using the curly brackets, so the lowest value is going to be -3, then -1, then 0, then 1, and 2, and 3. Use the curly brackets. Okay, again, the next one is discrete, so we're going from this value to this value to that value, right? Just listing the x's that it's a part of. So in the curly brackets, -2, -1, and +2. The next is our y values, so up and down. Our y values on the first graph, we're going up to +2 and we're going down to -1. So y is going to be less than or equal to the highest value, which is 2, and greater than or equal to the lowest value, which is -1. For the second example, discrete points, just listing those points. So lowest is -2, -1, 0, and 1. So -2, -1, 0, and 1. Put them in the curly brackets. Again, discrete points. We go in the y direction down to -3, -2, -1, 1, and 2. Those are our discrete points. -3, -2, -1, 1, and 2. Is it a function? Use your vertical line test. Crosses in 2 places. This is a no. Vertical line test, 1, 2, 3, 4, 5, 6. No points are crossed more than once, so this is a yes. The last example, the vertical line test, it fails here and here and there and there. So this one is a no. All right. The next example, again, discrete, which means just points, continuous, a line, but it either goes on forever or an arrow. If it loops back onto itself like this one, this is neither. This one is got lines with arrows, so this is continuous. And this is again a line with arrows, so this is continuous. The next for B is the domain. So domain is X. So X is going to be between the highest value, which is +2, and the lowest value here, which is -2. Looking at the second example here, this line goes on forever. So if it goes on forever and you stretch it, you'll see that it's going to continue to go to the left. And if we extend this one, it's going to keep moving, in fact, in the right direction. So it's going to go on in the left and the right direction. So in fact, X's are going to encompass all the real numbers because it's going to continue going left and right. For the third example here, there's only one value of X, which is -2. So X is equaling -2. It's a little bit different. You don't have a set of numbers. It's just one single number. Okay, for C, this is going to be our range, which remember is our Y values. So Y, whoops, I wrote X. Y is going to be between the highest value of 2 and the lowest value of -2. So the highest value is +2, the lowest value is -2. With the second example for our Y's, we can see that there's an arrow going up and an arrow going down. So in fact, this is going to continue on infinitely in both directions. So our Y is going to encompass all of the real numbers as well. And for the third example, our Y is going to continue down and up. So this is going to be, in fact, Y encompassing all of the real numbers. The last part of this is to determine whether it is a function or not. Use your vertical line test, fails here and here, so this is a no. For this one, the second one, just doesn't matter where we put our vertical line, it is going to, in fact, not cross more than once, so this one is a yes. And this one is a little bit confusing, right? When you think about it, there's a lot of points on this line that are going to be crossed with the vertical line. In fact, all of them. So this, again, is not a function. All right, one last example. Now, this one is a little bit different because, in fact, we have kind of 2 lines on the graph, okay? So let's start first to see if this is continuous, discrete, or neither. Now, because the graph is broken up, yes, it is a continuous line here, and it is a continuous line there, but it does not, in fact, join those 2 lines together. This one is a neither. Okay, with the X values, thinking left and right, okay, this arrow is going to continue on here and here. So in fact, it's going to go to the left and the right, and the same with this one. It's going to go infinitely to the left and the right. So in fact, X is going to encompass all of the real numbers. Now, for Y. Y, if we think about it, it's going to continue on going down here, but it's stopping there. And it's going to continue on up here, but it's stopping there. So Y can be greater than 2. So our Y can be greater than 2. It can also be equal to 2 because it's actually on that point there. And Y can also be less than 0. So less than or equal to 0. Okay? So, not 0, sorry. That point is -1. So it's x can be -1 or any number less than that. So it's going to be equal to -1 or less than that. Now what you'll notice the way we've written it is that we've actually got the lowest value on the right and the highest value on the left. If we flip this, we have to make sure that we flip the signs. So y stays in the middle, but now this opening is going to still be towards the y, and we've got the 2 on the right side. So the 2 is still on the less side, the small point, and the y is on the open side. And then flipping it this way as well does the opposite, so that y is less than or equal to -1, but y is greater than or equal to 2. Now, is this a function or not? Use your vertical line test, and it's going to cross more than once. So this is no, not a function. Okay, lots to think about. You in fact have a couple of assignments. Start with the first one because it's the easiest, and then move on to the second one. All right. Remember, watch the video before you do the assignments.